This is page 5 in your packet. Start off with a proof, trying to prove that two angles are congruent. We're given that we have congruent triangles, and so that's just a wealth of information for us. This triangle here is the same as this one, and by the way it's named, I know that ST and RT are congruent. TU and TU are congruent. SU and RU are congruent. Okay, I also know that angle S and angle R, which would be these, are congruent. Angle T is congruent to its counterpart at T. And the angle U's are congruent. Since they're congruent, I know they're going to be 90 degrees because they're also supplementary. Congruent supplementary angles have to be 90. So I have all this information just from this one statement. I also know that PQ and RQ are congruent. So I could list all these things out, but let's pick out which ones I actually need to know. I know that I'm eventually going to be trying to talk about angle S, so I want to mention that angle S is congruent to angle URT from CPCTC. Okay, and then if we end up needing something else from this, we'll use it, but for right now, that seems to be all I need. Over here, these two sides are congruent, which makes this an isosceles triangle, which also means that these opposite angles are congruent. So I'm going to say that angle P is congruent to PRQ from the base angles theorem. Now I can say that URT and PRQ are congruent because they're vertical. So angle URT is congruent to angle PRQ because they're vertical. And then I can say that angle S is congruent to angle P through transitivity, because S is congruent to here, this is congruent to that, and that is congruent to that. So I'm following a path. This is transitive, which is a combination of statements 3, 4, and 5. Here I've got an exterior angle that's 100 degrees. I know the exterior angles always equal the sum of the two opposite angles. So x plus 3x, which is 4x, if I divide by 4, x has to be 25. Here I still have an exterior angle. I can ignore this altogether, and that makes it more apparent that this is the triangle I'm dealing with. This is an exterior angle. So that exterior angle has to equal the sum of the opposite angles. So solving this, I can subtract the 12x over. I can add the 7 over. So x is 4. Here's another proof. This is the beginning of chapter 5. So this one's basic. Chapter 5 is where we first started talking about base angles and properties of isosceles triangles and things. So we're going to try to get ABG to be isosceles, which means I'm trying to get, okay, in order for me to get, if we kind of work bottom up, in order for that to be isosceles, two of these sides are going to have to be congruent. Okay, so the first step in front of this one, I'm going to need two congruent sides on triangle ABG. I don't know which two they are, but that's what I'm aiming for. I'm given that GE, which is here, is parallel to HF, which is here. And I'm given that angle A is congruent to BCH. So parallel lines are going to give me corresponding angles, alternate interior angles, all that. So I could say that this is congruent to that one, or I could say this one's congruent to that one, which helps because this is inside the triangle. So that's what I'm going to use. Angle ABG is congruent to angle BCH because they're corresponding. And that makes angle A congruent to angle BCH, or no, to ABG, sorry, from transitive, which is a combination of statements 2 and 3. Since these angles are congruent, I know that AG is congruent to BG from the base angle's converse. Which means ABG has isosceles by the definition of isosceles. Okay, now this is going to be kind of the granddaddy of all the questions in the packet because it's asking us to do a lot of stuff. It's also going to kind of force you to know what an altitude and a median and a perpendicular bisector are, as well as a centroid. Centroid is the closest to what we would usually consider the middle of a triangle. Okay, so there's 4 different middles. There's the centroid, the circumcenter, the incenter, and the orthocenter. They all serve different purposes, but the most practical one is the centroid because it's the balance point of the triangle. And when we usually think middle, we think average, just like when we're doing midpoint. Midpoint's really an average. Centroid is also an average. It's the average x and the average y. So I'm going to add all my x's together and divide by 3 because there's 3 of them. 4, -4 cancel, leaves 7. So my centroid is at 7/3 for the x. And the y, if I add these two, I get -2. Added to 5, I get 3 divided by 3 is 1. There's my centroid. The equation of an altitude. Well, an altitude is going to be perpendicular to a side and go through the opposite vertex. So if I choose A to be my vertex that I want to go through, that means I need to be perpendicular to the line that goes through B and C. So I'm going to find the slope. 5 minus -3 is 8. 4 minus 7 is -3. So that would be the slope of this line. I need to be perpendicular to that. So I'm going to flip and switch this. So it's 3/8. So that's my m that I'll use. So the equation is going to be y minus the y from the point I want to go through, which is this vertex, equals the slope I'm using, x minus -4, which is plus. Distribute, I'm going to 3/8 x plus 3/2. Then I need to add the 1 over, which would be 2/2, so that makes this 5/2. That's the equation of one altitude. Now, if I had chosen B to be the vertex, I would get a different equation. Same if I chose C. So there's 3 correct answers to this one. If you really want to test yourself, find all 3. Find a median. Okay, a median is a point that goes through a vertex and the midpoint of the opposite side. Okay, so if I'm going to choose A as the vertex I want to go through again, that means I need to go through this point, A. I need to go through the midpoint of this side. Well, the midpoint of this side is going to be 7 plus 4 divided by 2. So 11/2. And -3 plus 5, which is 2 divided by 2, 1. Okay, this is the midpoint of this side. I need an equation that goes through these 2 points. So first, I need to find my slope. So to find slope, I'm going to subtract my y's, subtract my x's. It really doesn't matter what my x's turn out to be because I've got 0 divided by something. So that means my slope is going to be 0. So y minus y1, so I can choose either of these to be my y1, equals my slope times x minus x1. This goes to 0. So y minus 1 equals 0. Add the 1 over. Okay, so it turns out my median here is a horizontal line at 1. So the value of 1. So that would look like this on a graph. This would be a median. Okay, now that's one median. There are 2 other choices. Okay, and they'll turn out to be something different. Perpendicular bisector. Okay, a perpendicular bisector is going to go through a midpoint and be perpendicular to the same line whose midpoint it's going through. I already have the midpoint for BC, and I already have the slope for BC. Okay, this is the slope of BC. Here's the perpendicular slope. So I can use those 2 things in conjunction to get the equation of my perpendicular bisector. But just to mix it up and show you another example, I'm going to pick a different one. So I'm going to find the perpendicular bisector of this side, AB. So I need the midpoint, add my x's together. I get 3 divided by 2, which is 3 halves. Add my y's together, I get negative 2 divided by 2, which is negative 1. So I need to go through that point. And I need a slope that's perpendicular to this one. So to find my perpendicular slope, I first need this slope. Negative 3 minus 1 is negative 4. 7 minus negative 4 is 11. Flip and switch that, I get 11 fourths. So that's the ML you're using. Y minus negative 1, so plus 1, equals my slope, 11 fourths, x minus 3 halves. Okay, because I need to go through the midpoint. Distribute, I get 11 fourths x minus 33 eighths. Subtract 1, which is the same as subtracting 8 eighths. And my equation is going to be y equals 11 fourths x minus 41 eighths. Okay, so that's one equation for one perpendicular bisector.